Hi, Mindsetters. Welcome to your exam school lesson for physical sciences on a Tuesday with Luni and Emmanuel. How are you doing, Emmanuel?
Hello, Luni. I'm doing great, and you?
I'm good, thank you. So what are we doing for the grade 11s today?
To the learners out there, today we are going to look at grade 11 physical sciences paper 1, and what we are going to try and do is to look at your question paper. In other words, we are going to look at electrostatics, we are going to look at mechanics, basically looking at Newton's laws. We are also going to look at forces. We are also going to look at electric circuits. So we will try and cover most of the parts that paper 1 exam will actually look on. So basically that's what we're going to have a look at. We've got a lot of questions that we go through, and we're just going to take it slow and ensure that at least we understand out there. Yes,
All right,
that's what we're
thank
going
you,
to have a
Emmanuel.
look at. Thanks.
Mindsetters, we are doing paper 1, so I hope you guys are excited and you prepped. You've got your notes because they've been posted on our Facebook page for a long time now, and you have everything you need. Remember, for all your other exam school revision notes and your videos, you can visit learn.mindset.co.za/extra/revision/exam school. And don't forget to hit us up on Facebook on facebook.com/learnextra. Our Twitter handle is @learnextra, and this lesson is proudly brought to you by the MTN SA Foundation. So thank you so much for that. With all of that said, Emmanuel?
Okay, look, we are going to have a look at the first question, and the first question that we have got on the board here is the question that that looks at electrostatics. So there's the question. Basically, this is the question that we have got. So they say this is a challenge question. They say 2 point charges Q1 and Q2, a distance 3 meters apart, are shown below. The charge on Q1, that's they've got a distance of 3 meters apart, and then we've got a charge Q1, which is actually we say there is 14 coulomb, and then charge Q2 is 20 microcoulomb. So that's minus 14 microcoulomb and plus 20 microcoulomb. They are separated by 3 meters. So this question here is a challenge question. So learners out there, please get down and have a look at this question. And then towards the end of the lesson, we are obviously going to have a look at this question, and I will provide you with how you should have approached this question. But the question that we are going to start with now here is a mechanics question, and this question looks at forces, and in this it reads as follows. Let me just say it reads as follows. They say Tato applies a force of 180 newtons on a block at 55 degrees to the horizontal. They say as shown in the diagram. They say the block remains what? It remains stationary, which means that it doesn't move, and we can see the block in there. So they say the first question, draw a labeled free body diagram showing all the forces acting on the block. And grade 11 learners out there, when we look at the free body diagram, remember, very importantly, when we say a free body, our block or our object, we represent it by what? By a dot. So I will first say, here we have got a dot that is representing our what? It is representing our object. And what is the first force that is acting on this object? So we have got, we know it's on the surface, so we can say we have got the weight of this object here. So there's the weight, so we can say that's W is equals to mg. That's the weight. Obviously, any object will have a weight. And then the other force that is acting on this object, remember they said we have got this force here. So that's our applied force. We can safely go there and say our applied force. There we are. So we have got our applied force. So we need to label that. So we say it's F up. And then what other force is acting on this object? Look at it here. This object is resting on a what? On a surface. So when an object is resting on a surface, obviously we have got the normal force, which is acting from the what? From the surface. So we've got the normal force that we need to put in over there. So we say we have got the normal force. I will say that's F normal. And which other force do we have? Note that they say here, this object remains what? It remains stationary. It's not moving. So in essence, we have to think, what is it that is making it not to move? Because we have got the applied force. Learners out there, because it's stationary, it means that there is another force which is actually making this object not to move. So look, if you look at it here, it means that you'll find that there is a frictional force which is acting on this object, and obviously it is equals to the horizontal component of Tato's applied force. So let's just get back and say the frictional force is always opposite, so it's opposite. In other words, I will draw it like that, say that's our F frictional. So that's our free body diagram in there. Remember, label every other force. Remember, they say that we must draw a labeled free body diagram. So remember, the dot represents the object in our free body diagram. Now let's move on and look at the next question in this question. They say the next question, which is question number 1.3, they say, find the coefficient of static friction between the block and the surface. Now, the coefficient of static friction between the block and the surface. But look here, that's question number 1.3. It means that we must have skipped what? Question number 1.2. Let's just go back there and say question number 1.2. Question 1.2 should be, let's just go back and say, let's just scroll down here and say, where's our question number 1.2? I'm sorry for that. Oh, there it is. So they say calculate the magnitude of the force of friction. So remember what I said, there is a force of friction, which in this case is equal to the horizontal component of the force that Tato is actually applying. So let's just get down and look at the frictional force that we have got. So we'll say frictional force, F frictional, is equals to, remember this object is stationary, so it's equals to F horizontal. Now, if we go back and say, let's look at our object. So if we are saying that this force that Tato is exerting is like that, that's our F applied, so we must have a horizontal component to this force in here. And how do we get our F horizontal? Our F horizontal in this particular case will say, okay, that's equals to, so if we say our F horizontal will be the F applied, which is the force that Tato is applying here. So we'll say this our F applied. Now remember our angle is there, so that's 55 degrees. This our F horizontal. So the adjacent over hypot. So this our applied is the hypot, and then our adjacent is the horizontal. So we can go back to our question and say, okay, so it means that we can say F horizontal divided by F applied is equals to adjacent over hypot. That's the what? That's the cos. That's the cos of 55. Meaning that our F horizontal will be equals to F applied, the cos of theta. Our theta in this case is actually 55 what? 55 degrees. And then it means that we'll say F applied, that's F horizontal is equal to F applied, the cos of 55. So that's 55 degrees. And then how much is our F applied? When we go back, the force that he is applying is 180 newtons. So we can say that's 180 the cos of 55 degrees. And how much do you get in that regard? And then yes, you will get the answer of 103.2 newtons. and that's the answer which you'll get. Remember, that's the magnitude of the what? Of the frictional force. Let's go to the next question now. The next question, which is question number 1.3, the question reads as follows. They say, find the coefficient of static friction between the block and the surface. Between the block and the surface. And learners out there, to actually calculate the coefficient of static friction in that regard, you can use the equation. Look at it. We say F S is equals to, we'll say mu, that's the coefficient of static friction, and then F normal. So here we should say that that's the F, the F that we should have here is FR. That's our friction, not FS as such. So let's just remove this. So I will say, let's just remove that. So I will write it nicely and say that's our F. I will say FR over there. So in this case, we have got FR is equals to mu s, which is the coefficient of static friction, multiplied by the what? Multiplied by the normal force. Let's just have a look at it and say, we have got the frictional force, right? We are looking for the coefficient of static friction. Do we have the normal force? Now, when you go back into the free body diagram that we drew before, you'll realize that if we look at this free body diagram, we have got the weight. And at this particular juncture, I must emphasize that when you look at it, the applied force does have the horizontal component. The horizontal component, which we have already calculated, and we also have the vertical component, which we didn't show it because we cannot show both the applied force and its component. So our normal force will be equals to the weight that we have got and the horizontal force. And let's just go and look at how we can work out that. So let's just get down. So our F normal, I'll just do it on the side. So it's F normal is equals to, that's our F vertical. So let's just say F vertical plus the weight. So let's just do it in a clear way down here. So I'll just show it here. So we'll say F normal is equals to F vertical plus the weight. So that's the weight. So we can just say W there. So remember our F horizontal was what? Was F applied, that was F applied, the cos of 55. Now we can say for the vertical, we can say is F applied, the sine of 55. So we can say for the vertical, we can say is F applied, the sine of what? The sine of 55. Plus W, which is our weight, we can say is mg, and our m, what is the mass of this object? So let's just first put it like this before we go and substitute. And then we can say, going down, is F applied, which is 180, multiplied by the sine of 55. And that's 55 degrees plus. Our m is 30. Multiplied by what? Multiplied by 9,8. And then the answer that you're going to get, let's just go and say where's our calculator. You can say that's the sine of 55. That's equals to, and then you say multiplied by 180. That's equals to, and then you've got that's 147, and then that's 147,447 plus, and then we go again and say after that let's just look at it and say we need, that's 30 multiplied by 9,8, that's equals to, we have got 294. So that's 294. And then you can go on and find what the sum is. Now, quickly, let's conclude by looking at the last question. They say, use Newton's laws to explain why the block remains stationary, even though Tato applies a force on it. Now, why does the block remain stationary? And to conclude, we can say the horizontal component and the frictional force are equal, and we don't have a resultant force, or the resultant force is 0. And according to Newton's first law, a body will remain at rest or continue moving along a straight line unless it is acted upon by an unbalanced force. So that body is not moving because the resultant force is 0. Thank you.
All
once
right.
again.
Mindsetters, we are going to take a break, so don't go anywhere. We'll see you straight after these. Welcome back, Mindsetters, from that break. So if you or your friends or your family have learners or driver's licenses and you want to win yourself one of 4 Chevy Spark Ls, so listen up. We want you to enter the Be a Bright Spark competition simply by buying the official Safeways K53 Learners and Drivers Manual from your major South African retailers. Keep the receipt or download the official Safeways K53 app from your Google Play Store for all you Samsung smartphone users, all right? And then once you've done that, you go to our Facebook page, which is facebook.com/learnextra. You go to the competition tab, you click on that, fill in all your details, and then you enter the competition. You share that as well. You share the competition with all your friends, and then you get an extra entry into the competition. Once you've done that, you like the official Safeways K53 Facebook page, as well as liking our page, and then you've entered the competition, and you'll stand a chance to win a Chevy Spark L. And remember, the first winner will be announced in 3 weeks' time, so on the 23rd of November. Make sure you are tuned into your screens and you're watching the show, because we'll announce the winner for the first Chevy Spark L, and then after that there will be 3 left to give away. So be a bright spark, enter the competition, and don't forget, we have a competition going on the official Safeways K53 Facebook page. We want you guys to caption the picture. There is a picture there of a doggy driving, and we want you guys to caption it, okay? You caption by commenting on that picture. The best caption will stand a chance to win a Google voucher with 150 Rand that you can use to download the app. Okay, guys? So be a bright spark, enter the competition, and you'll see you might win yourself that car. Emmanuel?
Wow. Welcome back, Lena. So we were looking at the question that has to do with forces, studies, and mechanics, and there is just one thing that I just want to emphasize in the question number 1.3 that we do. We're in a bit of a rush, and we couldn't finish that question. So I'm just going to go briefly, look back, and say how should we have actually concluded it, so that at least we are all clear as to what is supposed to be done. Now, let's just go back and say this question required us, we were required, or the question says, find the coefficient of static friction between the block and the surface, and what we went and calculated was the what? The F normal, in other words, the normal force. We should have taken it further and say, from that equation there, that's the equation that I'm referring to, we can then go on and say FR is equals to and then that's F normal. And remember, we have calculated F normal. We have already calculated the frictional force. And if you go back, you'll realize that our F normal, the one that we calculated there, we'll say that's the coefficient that we are looking for. And that's multiplied by the F normal that we have calculated, which is 4.45 newtons. Remember, you may not put in the units in there. And then, how much was our frictional force? We may have to go back to the question that we calculated our frictional force. And remember, our frictional force in that regard was 103.2. So we can, let's just go back and say our frictional force was 103. So that's 103. 103. Is it 103,4 or 103,5? Let's just verify that. 103, what? 103,2 rather. So it's 103,2. So let's just put that into perspective. So 103,2 rather. Where is that? So 103,2. 103,2. So we can divide both sides by 44,45, and you can do that, 45. And what answer are you getting, guys, out there? So the answer that you should have is, how much do you have? Let's just go and calculate that and say, if we say now we have got 103,2 divided by 44, it's supposed to be not just 44, but 441 rather. So just 441, let's just 441, 45, and we say, what is the answer there? And then we put it in that. So the answer there should be 233. And remember, this is a unitless what? A unitless value. We don't have a unit for the coefficient of static friction. Now let's move on and look at the question that follows. And this is the question that follows here then us. So they say, a ray of light moving from water to air strikes the air water surface with an angle of incident equals to 47 degrees. Determine if the light ray undergoes refraction or total internal reflection by finding the angle of deviation after striking the surface. Let me just read this question once more again. They say, a light ray moving from water to air strikes the air water surface with an angle of incident equals to 47 degrees. Determine if the light ray undergoes refraction or total internal reflection by finding the angle of deviation after striking the surface. After striking the surface. Now I must emphasize in here that to determine the angle of deviation, the law that we use in there is Snell's law. And I must also put it very clear by drawing this diagram to say that what is happening here, we have got a situation like this. So we have got, let's just say this, the surface that we have got. Let's just say here you are in water, and there that is air. That's air, rather this way. So we'll say that's air. So this light ray is actually moving from water, which is a surface which is much denser than what? Much denser than air, and then it's moving out to what? It's moving out to the air. And then we have got what we call the normal there. I actually want us to have a look at it in dotted lines so that at least we don't confuse it with our light rays. So I just want to put some dotted line. There you are. There you are. There you are. So this is water. This light ray is moving from this side and it's going, so it's moving from 1 to 2, from water to air. And then what's going to happen here, let's just also indicate that we have got the angle of incident. We also have the angle of refraction. Now that's incident, and then we will have also refraction up there. Now it is very important to know that in this particular case, if we want to find the angle that it will deviate by, look here, if the angle there is greater than or is equal to 90, if this angle here, the angle of refraction is equal to 90 degrees, it means that this light ray will not actually be seen out on the air. In other words, outside this surface. If this angle, the angle of refraction is equals to 90. If that very angle is less than, let's just say less than 90, if it is less than 90, then we'll see the light ray there coming out. And then if it is greater than 90, if that angle there is greater than 90 degrees, then what we are going to have is that we are going to have this light remaining inside here. So it will be internal reflection as such. Now let's just go and look, use Snell's law to actually determine our angle of deviation, and from there we can then say whether it just undergo refraction or it's just total internal reflection as such. So let's just go and look at that. So we'll say, according to Snell's law, we'll say N1, the psi of theta 1, so that's the incident one. So as it gets in, that's equals to, and then we'll say N, that's for this, in other words, this is for one surface, and then that's for the other surface. So N2, the psi of theta 2. And then as we move on, we'll say, look here, we are given the refractive The refractive index of air. In other words, where we have got N for water, we're going to put how much is 1. That's the refractive index of what? Of air. And then the refractive index of water is 1, what? 1,33. Now let's just go and proceed and say, okay, fine, it's moving from what? It's moving from water and it's going out into what? Into air. So we are going to say from water, what is the refractive index of water? We are told that is 1,33, so we'll say 1,33. And then the psi, what is the angle of incidence they've given us there? How much is it? That's 47 degrees. So we'll say that's 47 degrees. And that's equals to, out there in the air, what is the refractive index? That's 1. And then multiply, we should have said the sign, not just as over there. So that's the sign. That's the sign. So that's the sign of theta 2 over there. So multiplied by the sign of theta 2. So this is the angle that we want out there. So we'll say the sine of 47, let's just use our calculator there. So we'll say sine 47, sine 47, that's equals to, and that's multiplied by 1,33. That's equals to, and then we say that's comma, just get that back, it's comma 972. So comma 9727, comma 9727 is equals to the sine, rather say the sine of theta 2. So the angle that we are going to have there, so I say theta 2, or let's say theta 2 is equals to, now let's just go back to our calculator and we'll say, just say I would say second function sine of comma 9727, and then that's 76,581. So that's equals to 76, let's just check that answer again, 76,581. So we can say 76,558 degrees. Now, that's the angle that we have got. And remember, here we are saying that it means that it moves away from the normal by how much? By 76.58. How much is our deviation? So the angle of deviation, therefore, deviation will be equal to 76.58 degrees less the angle that the incident angle, which is actually 47. Now we can just quickly go and say less 47. That's equals to 29.58. So that's equals to 29.58 degrees. Now, going back to answer our question, if we look at it and say, what was the question all about? They said, determine if the light ray undergoes refraction or internal reflection by finding the angle of deviation after striking the surface. We have got the angle of deviation, and remember, if it is less than 90, what does it tell us? Remember, if it is greater than 90, it will be internal what? Internal reflection. But if it is less than 90, it means that it's just a what? A refraction. So therefore, we can say that it underwent what? Refraction. That's refraction. Okay. So that's it as far as the question on light is concerned. I must emphasize that wave, sound, and light is a very important topic that you should ensure that at least you know it well, know your waves, the basics of longitudinal transverse waves, as well as these light aspects of it as well. So we can move on now. We're going to look at the next question. The next question that we're going to have a look at is actually the question that has to do with Newton's law. Now we're just going to read it and then get down and look how far we can get with this question. Now the question reads as follows. They say, consider the diagram which is not drawn to scale. So this is the diagram that we have got. They say, calculate the magnitude of the gravitational force on the moon due to the Earth and sun in the position shown in the diagram. Now, this diagram here does have a lot of information. The information that we are given, the distance from the sun to the moon, the distance from the moon to the Earth. We are also given the mass of the Earth, the moon, and the sun. Now, very important. When we look at it, we want to calculate the force that the moon will experience due to the what? Due to the sun, and due to the what? To the Earth as well. Now, quickly, let's just go and say, how do we deal with it? Now, we are just first going to look at what is the force that the moon will experience due to the what? Due to the Earth. And how do we calculate that? We will say that is G multiplied by that mass of the, we'll say mass of the Earth multiplied by the mass of the what? Of the moon divided by R squared. Now remember, when we say R, we are talking about the distance between the two. In other words, the distance from the center of the moon to the center of the what? Of the Earth. And then it is very important for us to know that G is a constant, and we know that is 6.67 times 10 to the power of minus 11 multiplied by what is the mass of the moon. The mass of the moon that we have got, we say, if you look at in the diagram that we have got there, they say the mass of the moon is 7.35. So 7.35 times 10 to the power of times 10 to the power of 22. So that's just remember this one should be for the earth rather. We first have to deal with the one for the earth. So the one for the earth we say is 5,98. Quickly, 5,98. 5,98 times 10 to the power of 24. 24 multiply. You can squeeze in there the one of the moon, which is, we can say, is 7,35. 7,35. 7,35 times 10 to the power of, can't write in there, to the power of 22. So you can divide by the distance there, and they say the distance between the two is 4 times 10 to the power of 8 meters, and then we have to square that one. So you find that distance first. Now I must say that we are running short of time, so we are going to actually stop here. What you have to do, find those forces, and then after finding those forces, you can use the theorem of Pythagoras, find the hypotenuse, because the force that is actually experienced by the moon will actually be the hypotenuse side, because we have got two, remember from the earth to the moon is perpendicular, and from the sun to the moon as well is perpendicular. So you can use Pythagoras theorem. Thank you very much, and we can move on.
All
Thank
right.
you. I think I took a lot of time there.
No, it's fine. Mindset is we are going to take a break. Let's take that break, and then we'll see you straight after this. Welcome back, Mindsetters, from that break. So I told you about the Be a Bright Spark competition. We also posted a question on our Facebook page about last week, asking what you guys think of buying your driver's license. So instead of going through that whole thing of doing your driving lessons, going to get tested for your driver's license, you actually buy it. We want you guys to share your views on that and post all your views on our Facebook page. And then don't forget to also do your K53 Curio quiz. I've posted the link on our Facebook page as well, so do that so that you can get an extra entry into the Be a Bright Spark competition. All our information is on the Facebook page about what you need to do, and the link for the quiz is there as well. So do that and enter the competition, and you might stand a chance to win that Chevy Spark L. Emmanuel.
Wow. Okay, now thank you once again. Let's proceed, and now we are going to have a look at the next question. I will come back to the question that we didn't finish earlier on, but let's just go and look at the challenge question. Remember the question that I gave you earlier on? Yes, that's the question that we're going to have a look at. Let's just quickly go and have a look at it and ensure that at least we understand what it all requires us to do. So the question reads as follows. They say, two-point charges Q1 and Q2, a distance of 3 meters apart, are shown below. The charge on Q1 is minus 14 microcoulomb, and the charge on Q2 is 20 microcoulomb. And we can see the diagram there. They say calculate the net electric field at point P, situated 2 meters from Q2. So now let's have a look at it. So we are saying that we want to calculate the net electric field at point P. This is our point P in there. So how much is our net electric field? Now the first thing that I think we should first do is to calculate the electric field due to the point 1. Let's just consider Q1 as our first charge. We'll say, okay, how much is the electric field on P due to what? To Q1. We can say E is equals to, that's E for electric field, and then that's equals to K Q1 divided by what? Divided by R squared. That's for the what? For the electric field in there. So we can say our K, we know that is 9 times 10 to the power of 9 and then that's our K, and then we say multiplied by. Let's just look at our Q. So how much is our Q? Our Q1 is minus 14 microcoulomb. We can safely say is 14. So remember, when we say micro, is times 10 to the power of what? To the power of minus 6. And then divide that by the distance between the two. So if it is 3 meters from there to there, and it's 2 meters from there to there, how much do we have between there, between Q1 and P? So obviously we have got 1 meter in there. So we can safely go there and say we have got 1 meter. So we remember that is squared. So we can go there and say, let's use our calculator. We're going to say 9, and we say exponent 9, and then we say multiplied by. That's multiplied by 14 exponent negative 6. So that's negative 6. That's equals to. So that's 1, 2, 6, and 000. So we can just write it as 1, 2, 6, and then that's 0, 0, 0 watt. You remember, this is a electric field, so that's a Newton. That's newtons per watt, newtons per coulomb. So that's force per unit charge in there. That's electric field due to Q1. So let's quickly move and look at electric field due to Q2. So we'll use the same equation, and then we'll say E is equals to K Q2 divided by what? Divided by R squared. And as we go down, we'll say that's 9 times 10 to the power of 9 multiplied by. How much is our Q2 in there? Our Q2 is 20 microcoulomb. So that's 20 times 10 to the power of negative what? Negative 6. I must just write clearly here. Our multiplied by is not very clear. Let's just get that clear. So that's 20 times 10 to the power of minus 6. And that's divided by, and what's the distance between Q1 and P? This is the distance that we are talking about. The distance in between is how much? Is 2 meters. So we can put 2 there. And don't forget, we should square this. And then, let's just say, that's equals to, I'm just going to extend my page in there. And we're going to have, let's use our calculator. So it's, we've got 9 exponent 9. Let's delete that. So we'll say 9 exponent 9, and then that's multiplied by 20, and that's exponent negative what? Negative 6. We got that one, and then divided by 2 squared is how much? Is 4. Divided by 4 there. How much do we have? So that's 4. Is it 4,500? So they just verify that. So that's 45,000. That is newtons per coulomb. And then as we move forward, we can safely say, okay, the net, so we can say E net is equals to the field at point P due to charge 1 plus the field at point P due to charge 2. And we can just proceed and say that's equals to, for the first one, remember how much do we get? We got 126,000. So that's 126,000 plus how much did we get now? We got 45,000. And then if we add 126,000 and 45,000, let's just get that one right, to say plus 126, 126, 000 there. How much is our answer? That's 171. So let's just say 171,000 newtons per what? Newtons per coulomb, which is basically, we can say that's 171 times 10 to the power of 3 newtons per what? Newtons per coulomb. That's the net electric field that is experienced by what? By P at due to charge Q1 as well as what? As well as charge 2. So I hope you got that one, because obviously we have posted that on Facebook in there. So just check it and then ensure that you understand how to get around this. Now let's proceed, and we are going to look at the next question now here, which is question number 5. Now, question number 5 is basically looking at electric circuits, and let's just quickly go and look at what it entails. They say a number of meters and resistors are connected as shown in the diagram. They say a 3 volts battery is connected to terminal X and Y. Now, let's just go down. Determine the reading on voltmeter V1. Now, how much does V1, look at where V1 is, how much does V1 read? Now, we are told from the beginning, they say a 3 volts battery is connected to the terminal, to the terminals X and Y. Now, in other words, here and there, that's across X and Y. So, if we have got that battery connected in this circuit, then how much does that read? So in other words, if we look at it carefully, we will be right if we say the reading of V1 reads how much? That's 3 volts. The reading of V1 is 3 volts. Let's just make it clear and nice over there. So we can say the reading on V1 is equals to what? 3 volts. Now, that's easy, isn't it? So let's just go and look at the next one. They say, calculate the reading on A. Now, look here. When we say A, we are referring to the what? We are referring to the ammeter that we have got in our circuit. Now, very important, you should be able to notice, like, where is your ammeter? Where your ammeter is very important, because it will help you to determine what is the reading on it. In this case, the ammeter that we have got is actually across in one side of our parallel combination. We have got a parallel combination here, we have got this one side there, we've got another side, but the whole of this is actually what? A parallel combination. Now, this ammeter here is reading the current, the rate of flow of charge between 2 ohm resistor and the what? And the 3 ohm resistor. Or in that side, in this side, the current that is flowing will actually be read by this particular ammeter in there. And guess what? We have to go back and say, which law do we use? We use, of course, Ohm's law. And what is the equation that we have got for Ohm's law? We'll say, okay, we know that we are looking for I in there, but then for Ohm's law, we'll say, okay, we know is R is equals to V over I. I must emphasize that you must take the equations as they are written in the data sheet, copy them verbatim, because that's very important. You actually get marks for equations in some instances. Let's just get back to that. So the resistance that we are talking about here, look at where this ammeter is situated between 2 ohm and 3 ohm. So we can safely say, what is the resistance in there? They are connected in series. So we can safely say, okay, fine, that's the resistance of the 2 ohm and the 3 ohm resistance. That is just to actually identify them. And then the potential difference, remember the potential difference in the parallel combination is the same. So we can safely say V parallel. And then the current in there, we are talking about the current in the side that has the 2 ohm resistor and the what, and the 3 ohm resistor. That's just to identify, guys. So let's proceed. So the resistance of the 3 ohm and the 2 ohm resistor, if you can look at them, they are connected in series, so we can just add. So how much is 2 plus 3? 2 plus 3 is actually 5. So we can say that's 5 is equals to V parallel. That's the potential difference in the parallel combination. How much is that? We can say is 3. That's what we have already calculated. And then how much is our, we are looking for the current. That's the current reading in our ammeter. And then that's in the 2 ohm and 3 ohm section or segment. And then we can safely say I is equals to, and then if you go to your calculator and say how much is that, so it's if you put I as the subject of formula, you find that you now have 3 divided by 5, which will give you 3 over 5, which is obviously 0.6. So you have got 0.6 amperes. Now that's the reading in what? That's the reading in your ammeter in there. So that's the reading in your ammeter in here. The reading in there is how much? Is 0.6. Now let's move on and look at the question that follows. So the question that follows reads as follows. Let's just read that one out. They say, calculate the reading on voltmeter or on V2. So let's just look. Remember, the position is very important. So there's V2. Now, V2 is connected across what? The 4 ohm resistor. Obviously, we know the resistance there is how much? Is 4 ohm. Do we have the current? No. But then we know that the potential difference in a parallel combination is the same. So the potential difference in this side is 3 volts. So what we can do is to go and calculate the current that is passing through there as I'm using the potential difference and the resistance of the 2 resistors. Let's just quickly go and do that. So we can say the resistance of that's the 3 and the 4 ohm resistor, 3 ohm and the 4 ohm resistor. That's equals to, when we add that, how much will that be? That will be 7. So let's just go and look at that. That will be 7 ohms. We can go there and say now we know that V parallel is equals to 3 volts. We can then go and say R is equals to V over I, and then your R is 7, your V is 3. Remember, that's V parallel 3 over 4, and then divided by your I. And then you can calculate what your I is, and if you use your calculator very well, you'll find that you have got your, okay. So let's proceed and say, if you'll determine your I there. After getting your I, quickly, you'll go back and say, by the way, the resistance there is how much? Is 4 volts, and you use Ohm's law again to actually determine the resistance that is there in the potential difference that is there in the what? In the 4 ohm resistor. So that's how you will get it. Obviously, we have posted the solutions for this in the Facebook, so you can go through it and understand how to get through it. Thank you very much, and I so believe you have actually gained a lot from this lesson.
Thank you, Emmanuel, for the great lesson. Mindsetters at home, thank you so much for tuning in. We're wishing you everything of the best with your exams and all your preparation. Don't forget to not tune out of this channel, because after this we have a pre-trip inspection insert, so you guys can learn more about driving and what you need to know about your test as well. So thank you so much for tuning in. Thank you to the MTN SA Foundation for this awesome lesson. Until next time, guys, from us, we love you very much and goodbye.
Cha-cha.